Am I audible? I'm audible, right? Shikarani, so have you mic check? Yeah. So Shikarani, have you just watched the yesterday's session, the recording? So just let's wait for 2 more minutes and we will start the session. Okay. We will exactly start the session at 7:20 p.m. Yeah, we can start the session. So before that, can someone just confirm me whether you are able to hear my voice or not?
Yes, you're audible. Yes.
Okay, fine. Thanks for the confirmation. So today we will be discussing. So till today we have completed the basics of PCB designing, how PCB is manufactured, the different kinds of chemicals that are being used, right? And we discussed about FR4 material, and just yesterday we discussed about consumer safety. So about ROHS restriction of hazardous substances, and a few compliances, environmental safety and consumer safety. And we also discussed the different processes involved in PCB manufacturing like etching. So today we will be going in detail about etching procedure, what kind of how the chemical reactions take place, what kind of chemicals are being used for etching procedure. And today we'll be taking today we'll be going through few case studies. So as the title suggests, the hidden cost of circuit boards. So few circuit boards uh, has taken the lives of common people. So today we will be discussing the real world case studies on environmental and human health impacts of PCB manufacturing. So this is case study one, which happened in Silicon Valley. So we know that Silicon Valley is very famous for manufacturing of. Yeah, still someone trying to join. So today we'll be discussing about real world examples. So PCB, designing a PCB is not just fine. We need to know uh, the good practices of manufacturing PCB. Just yesterday completed. We discussed about 10 substances which are banned, uh, are restricted in during the manufacturing procedure, right? We discussed about ROHS compliance, restriction of hazardous substances. We discussed about polybrominated biphenyls, polybrominated diphenyl ethers. So they are very carcinogenic and cancer-causing substances. So they are basically used along with FR4. A small proportion of these chemicals are used in FR4 as a fire retardant, but the European Union passed ROHS compliances that they should be restricted because it is causing cancer. So today we'll be discussing about the hidden cost of circuit boards. The hidden cost means the PCB has taken the lives of people, which is very valuable. So you cannot um estimate the price of your life, right? So some PCBs have taken so it's not only just PCB, the poor manufacturing practices and the poor disposal methods, so handling improperly. So there are multiple reasons, there are multiple things which caused, which has taken the lives of the common people. So today we'll be jumping into some real world examples. Yeah. So those who attended a little bit late, the title is the hidden cost of circuit boards. So PCBs have some certain PCBs due to the improper handling, poor disposal methods, improper handling, all these caused. So whenever we are manufacturing a PCB, we need to make sure that the consumer also should be handle it very carefully during disposal. So improper handling results to severe consequences. So yesterday we discussed about ROHS complaints, restriction of hazardous substances. And we discussed about polybrominated biphenyls, polybrominated diphenyl ethers, so lead, mercury. So like that we discussed 10 materials, right? 10 banned substances. So today we'll be discussing the hidden cost of circuit board. So the case study one, Silicon Valley. So we know that Silicon Valley is very famous, right? It's a very famous where semiconductor industry, many kind of integrated circuits. So lots of technological advances are happening there at Silicon Valley. But the Silicon Valley is now converting into a toxic, a toxic area. So in 1981, there's a company called Fairchild Semiconductor. They discovered a massive leak from underground storage tank in South San Jose. It's an area, South San Jose. So all this happened in 1981. So around 60,000 gallons of solvents, primarily trichloroethane, TCA, which means trichloroethane. This trichloroethane is used as a solvent during the PCB manufacturing procedure. This is one of the chemical used as solvent. Guys, kindly please join in time. If you join little bit late, you may not be able to understand what's the thing going on. Because if I always repeat the same thing again, other people may feel a little bit inconvenient. So kindly please join in time. Today we'll be discussing about the hidden cost of circuit boards. So the PCBs have taken lives of many common people. It degraded the environment. We will be jumping into some real world case studies. The first one is Silicon Valley. So Silicon Valley is it's like where the boom of a semiconductor is going on. So many semiconductors are manufactured. The industry has started very early at Silicon Valley because semiconductors are very available, prominent in those areas. So the first example is the Los Pasios contamination. So in 1981, Fairchild Semiconductor discovered a massive leak from underground storage tank in South San Jose. It's an area so where around from the underground tanks, around 60,000 gallons of solvent, that is trichloroethane, has been leaked into the public drinking water, public drinking well. So this TCA trichloroethane is used for as a solvent. So from tomorrow, if anyone joins a little bit late, we will directly deny instead of joining into the meet. Kindly please join in time. So in the first case study in 1981, there's a company called Fairchild Semiconductor. they discovered a massive leak from underground storage tank in South San Jose. Around 60,000 gallons of solvent TCA, trichloroethane, which is used as a solvent in PCB manufacturing procedure, has been leaked into public drinking well. So it is very toxic and it is used as a cleaning flux and degrazing. It is used for degrazing printed circuit boards. So whenever any grease is there on a PCB, this is like a degrazing agent. It can remove the grease. So it is also called as a cleaning flux. It is very widely used in PCB industries. So whenever it got accumulated into the mixed with the public drinking well, so around 60,000 gallons of solvent. It's not just a small amount, a very huge big amount. Around 60,000 gallons of solvent, trichloroethane, has been leaked into the public drinking well. So this has been identified in 1981. So and many people used to drink the same water, the animals, right? And the people who are nearby that area. So it has, the water from the well has been distributed through pipelines, so everyone used to drink the same water. The contaminated groundwater was distributed directly to the nearby Pasios neighborhood. So whoever nearby that Las Pasios, that public drinking well, uh, everyone used to drink the same water, and the water has been contaminated. The same contaminated groundwater was distributed through thousands of residents. So knowingly or unknowingly, right? Usually, knowingly, no one used to drink the water. So unknowingly, thousands of residents exposed to the contaminated water. They drank it, and it resulted in a very very severe adverse effects, health adversities. So after that, as time passing by, so scientists have discovered that uh, during whenever a baby child is getting taking birth, so around 31 birth defects are documented. So different babies having some kind of birth defect. So there are total 31 birth defects have been identified and documented. So there are still many undocumented birth defects. So following the leak, residents of Los Pasios documented an abnormally high rate of miscarriages and severe birth defects, particularly congenital heart anomalies. So many of the people started getting congenital heart anomalies, something like a cardiovascular disease, so cardiological related disease. So 31 birth defects have been identified in the infants. So the infant mortality rate has been increased, and many people started researching on it. They found that due to the contamination, due to the dissolution of 60,000 gallons of solvent, a huge amount of trichloroethane into the public drinking well is the primary reason that resulted into congenital heart anomalies, cardiovascular diseases, miscarriages, increased birth defects, and mortality rate. So this is all caused due to trichloroethane, a solvent. And then one more case study we have. So we are having a video before going into PPT. It's better to show you a video. So let me reshare my screen again with audio. So now we'll be presenting a video. This is the credits go to actual owner. We are just presenting the video for educational purposes. So just watch the video. I will ask you the observations, what you have observed in the video. So everyone need to share at least one point from what you observed in the video. So before that, can someone just confirm me whether you are able to hear the audio of the video? Just raise your thumb or else raise your hands or else, yeah, fine. So just watch the video. So everyone need to share at least one point. The growing consumption of digital products is generating mountains of e-waste, whose disposal is posing serious health and environmental risks. So here in the map, a particular one region is being shown uh, in China. It is being shown in the map. So it is actually very famous where the many of the e-electronic waste disposal usually takes place. It's like a trade center for e-waste. So they use it to extract, even the PCBs and may contain some valuable materials, right? Something like copper, and copper is or else silver sometimes, and gold sometimes. So they used to extract different kinds of useful material from that. But the disposal method that they are following is really not good. So they are not following the proper disposal method standards. And yeah, so this is very famous. It's like a walls e-waste capital. They used to generate a lot of a capital from the e-waste. So it's like a disposal center, but the disposal methods that they are following are not are causing, lots of severe health issues and the environmental degradation. So biodiversity is being degraded, the ecosystem is being disrupted, and contamination is the fumes which are getting emerging out from the e-waste. Uh, these are causing, whenever it is being inhaled by people nearby that area, are getting lung pulmonology related diseases, pulmonary infections, and shortness of breath. And the fumes also causes uh, dermatological skin related issues and heart cardiovascular related diseases. So it's like a world's e-waste capital. And so a case study has been conducted by the Shantou University Medical College in 2014, found that children in the town had high levels of lead in their blood. So just yesterday, we discussed about ROHS compliance, restriction of hazardous substances. So among them, the very first substance that we discussed is lead only. So if you do not remember, you just go back and check the video. The very first substance we discussed in the ROHS, restriction of hazardous substances. The very first substance is lead. Then we discussed mercury. So later we discussed about polybrominated biphenyls and polybrominated diphenyl ethers. Right? They all are causing. They are having high toxicity and carcinogenicity. So it is found that in 2014, a medical college conducted a case study, and in 2014, they found that the children nearby that town having high levels of lead in their blood, which is very toxic substance. So finally, it became a national embarrassment for the nation, right? China. So later they started establishing more than 1200 workshops where these are consolidated they are consolidated into 29 big recycling units. So as you can see, they have invested $233 million to deal with this situation. So prevention is better, right? So always we remember one slogan that prevention is always better than curing, right? Always the prevention rather than getting a disease. First we need to taking medicines later, but instead of that, first we need to avoid try to prevent getting the disease. So similarly here, later they have taken multiple steps. They have invested $233 million to set up to deal with the situation. established 1200 workshops, which were later consolidated into 29 big recycling units. But all these things are caused due to the improper dealing, improper management of e-waste. So, so that's why it is. Today we are discussing all these things with you because we need to. At Suchana, we always try to bring an engineer into the society who not only just manufactures the PCB at the highest standards and professional standards and quality, but also should be very aware of environmental safety and consumer safety. They are most important. We should give highest priority to both consumer safety and the environmental safety. If you use any kind of hazardous substances during the manufacturing procedure, so they will adversely affect the biodiversity. So they disrupt the ecosystem, and the water gets contaminated. The fumes, uh, which may contain high levels of lead, if they get contaminated in, they may mix into the water, drinking water, and the water gets contaminated. Groundwater gets contaminated. This will be supplied to all the residents nearby area, so they will be drinking that, and the levels of lead and other toxic substances, mercury, so they will get increased in their body, in their in their blood levels, and which may leads into severe consequences, ranging from dermatological issues all the way up to cardiological and neuro related issues. So that's why we need to make sure that first we need to try to prevent it, right? So finally, they established different kinds of workshops to deal with the situation. They invested huge amount. So all these costs is because of the improper management of the e-waste. So finally, they started showing the slogans. We will protect our nation for our future generations. So this is how the situations changed. Initially, the people itself, they wanted to extract materials like gold, silver, and other important valuable materials from the PCBs. So few scholars, they thought that yeah, we need to, we should become a world's trade capital for e-waste. Finally they became, but this is not actually the intelligent thought, right? So the scholars might believe they are the intelligent people in the world, but what actually happened? So they themselves fell into the tragic consequences, and their health was very disrupted. So yeah, so not only their health, the people who are around uh, that specific area where this e-waste is being disposed improperly, so everyone got affected. So finally, again, the people started showing the slogans, we will protect our nation for our future generations. So many people have boycotted it. So they are very unsatisfactory with what's happening, the situations, uh, the disposal methods of e-waste. So this is how the situation changed. So the prosperity of the lives have been degraded. Their health has been degraded. Biodiversity is affected. The ecosystem is affected. So lead and many toxic substances have been accumulated uh, into different organisms, not only just humans, also accumulated into animals, right? So finally, in 2017, Beijing notified World Trade Organization that it would cease 24 kinds of waste imports by the end of the year. So earlier they used to import all kinds of e-waste. No, suddenly in July 2017, as the protests are going on, so due to the ongoing circumstances and contemporary issues happening at that time, so finally the Beijing notified the WTO, World Trade Organization, which usually supervises all these kind of trade activities, that they are seizing 24 kind of waste imports by the end of the year. So the credits of the video goes to the Hindu. So this is the first video. We have one more video for you.
Ryan, great quarter. Diana?
Before that, let me check whether the live streaming is going on or not. Okay, fine. I think it's going on.
Excellent work. Oh, Mark, 9 years this month, right? Yes. Wow, that's something.
Shipped in from
See how the waste is being disposed. So towards the left, we have the water body, and the waste has been being disposed improperly, right?
around
So there is no proper disposal methods they are following. They are throwing the waste. So this may mixing with the water. So see how recklessly, how carelessly they are dealing with the e-waste, which is really very serious because PCBs definitely may contain some portion of lead and other toxic substances. In the FR4 material, they use different kinds of even uh, different different kinds of fire retardants, which are very uh, toxic to human beings and animals as well, all living organisms. So they are having high carcinogenicity property.
the world to one of the main ports for solid waste, some of the millions of tons of scrap metal that China processes every year. Among the most valuable scrap, e-waste from the last generation of devices the world no longer wants, from laptops to mobile phones. In nearby villages in this part of eastern China, evidence everywhere of the hazards caused by recycling toxic components. A government crackdown on unregulated processing has forced recyclers to take refuge in
So do you know what they are actually doing? They are trying to extract some valuable materials from old generation e-waste, including silver and some other valuable materials. They are trying to extract it from it, but they are not aware of the consequences, uh, later consequences that will happen.
sealed yards. A potential resource, but a pollution nightmare.
So on one side we have a river body, and on the another side we have households, right? So there are many houses just besides the e-waste. That will be clearly portrayed in this video. You can see
It
it.
is a nuisance
See,
too for those people.
so he is one of the a household person. So if you just open his window, you can see tons of millions of tons of e-waste being uh, thrown over there improperly. So very poor practices.
Lucky enough to live next to the port.
So how many of you want to live like this, just besides the dump, e-waste dump? How many of you want to uh, live like that? So no one aspires to live like that, right? No one aspires because it is very dangerous. It will affect your health.
The situation is worse now compared with when we moved in a
So
few
he's
years
one of the
ago.
resident. So he's just speaking about his experience, how it's
The
there.
pollution is
I'll try to enable the captions.
more serious and it's very bad for our health.
While more than 2/3 of the world's scrap devices find their way to China, an increase
So around 2/3 of the world's waste, e-waste produced every year annually. So they reach the China at this region. So this is where your e-waste, maybe the smartphone or anything that you know, if you throw it somewhere else, probably there's a high probability that it reaches this region. So this is how the economy, their world's e-waste economy is growing for China, but at the same time, severe health consequences. People are getting affected. The nearby residents, so they cannot survive over there. The air is also contaminated. The fumes from the highly toxic substances, so they are causing severe issues. So around 2/3 of the world's e-waste reaches this specific location in China.
amount of the e-waste being processed here is homegrown, a trend that will continue with rising affluence. At a plant outside Beijing, some of the TV and computer monitors on their way to a new recycled existence. Able to handle nearly 2.5 million devices per year, this plant is operating at about 2/3 capacity. But it won't be long before China's appetite for newer devices means the plant will be operating at full strength. Appetite for newer devices. But it won't be long before China's appetite for capacity in devices per year. This plant is operating at about 2/3 capacity. But it won't be long before China's appetite for newer devices means the plant will be operating at full strength.
The amount of e-waste keeps increasing. As Chinese people see their living standards rise, people are buying a wider range of electronics and dumping more of their existing devices.
With currently less than 100 plants like this one operating throughout the whole of China, it is a sector that is set to expand. A new growth business making a living from outdated technology. Rob McBride, Al Jazeera, Beijing.
In the rupees 9 workshop that you're providing, what all do you cover?
In 9 rupees, you learn how to automate.
So that's the situation in China, right? So technological advance should increase the prosperity of human life. Uh, the standard how a common person lives, it should increase the prosperity, but it should not degrade. It should not take away the lives of the people, or else it should not degrade the environment. But that's what happened in China. So now the government is also taking some strict actions, imposing the restrictions on the imports of around 24 imports have been for 24 kinds of materials. Restriction has been imposed by the Beijing, and it has been notified also to the World Trade Organization. Around 2.5 million devices are being processed every year. So in the around the two-thirds of the world's e-waste reach there, the same processing units in China. So this is the situation. So the polybrominated, so just yesterday we discussed these two chemicals, polybrominated biphenyls and polybrominated diphenyl ethers. Just yesterday we discussed its structure, uh, and I have shown you the images as well. So these polybrominated biphenyl and polybrominated diphenyl ethers are halogenated chemicals. Historically, they have been embedded deep within the FR4. So you know about FR4, FR4 fire retardant 4, which is used as a base laminate material for manufacture of PCB. So these two chemicals are being embedded. These two halogenated chemicals are embedded deep within the FR4 epoxy matrix. So they prevent them from catching fire during the operation, during the manufacture procedure, and during operation. So the informal dismantling. So for decades, the city, which is the world's largest e-waste dump, hundreds of thousands of informal workers dismantled PCBs manually, so completely unprotected. Even the people who are dismantling the e-waste, they are not using any kind of personal protective equipment, PPEs. So they are without any protection. Directly they are exposed to the toxic materials. So they are like a petty workers. And the crude desoldering processes exposed workers to extreme levels of vaporized lead, while burning cables and circuit boards blanketed the entire town in a highly carcinogenic dioxins and polybrominated diphenyl ethers. So not only those workers and not only those processing units, but the entire city was exposed because the air has been contaminated, right? So the entire city became carcinogenic because of the emissions of the dioxins. So dioxins are one of the causes for these kind of chemical I mean the health adversities. So the level of PBD is polybrominated diphenyl ethers found in fish and shellfish in the rivers around the active e-waste sites in China were around 15,000 times higher than the normal. So this is not my word. It is extracted. This code has been derived from the IUPAC, International Union for Pure and Applied Chemistry Technical Report, IUPAC Technical Report. So according to their report, the levels of polybrominated diphenyl ethers found in different aquatic organisms like fish and shellfish in the river. So the levels of the PBDE is like around 15,000 times higher than the normal allowed level. So this is happening near the active e-waste sites in China. So we are having a fact check here, the chemical reality. So the trichloroethane which is used the role of trichloroethane in PCB manufacturing. It is used as solvent and a degreasing agent, and it affected many people. It was mixed in the groundwater and a nearby drinking well, and it got supplied to the entire. It supplied the water to the entire town, and the water gets contaminated, and people got affected. So this happened in this location. So if you want, there are multiple articles published. You can find them in the Hindu newspaper, and there are many articles published on these things. So you can, these are the real incidents happened. And polybrominated diphenyl ethers and polybrominated substances, and they are used as flame retardants in FR4, fire retardant 4. So they have caused endocrine and immune system disruption. So the immune system is also affected. So this happened in this city in China. And lead and cadmium. Yesterday we discussed lead is also lead and cadmium, and including these substances, polybrominated diphenyl ether and polybrominated biphenyls. So these substances are already included in the list of ROHS, restriction of hazardous substances, by European Union. So these lead and cadmium material are used in as a shoulder material and surface plating in PCB manufacturing, and they have caused severe neurodevelopmental damage. And we have already seen that due to the exposure of these chemicals, the mortality rate, the infants are getting the defects of birth. Around 31 birth defects have been identified by the researchers and the scientists. So even the neurons, whatever the neurons that we are having, they are getting uh, damaged. So many neurological issues are being occurred. Dioxins and furans, these are the byproducts that will get emitted during the burning of circuit boards. They are highly carcinogenic. They are the air become carcinogenic, and this happened in these specific cities of China. So this is about how the PCBs. So as the title of the PPT suggested, the hidden cost of circuit boards. So it has costed lives of many people and many organisms, fishes, different organisms, the birth. I mean, even the babies. If you just check the mortality rate, infant mortality rate, suddenly increased in the graphical representation. Suddenly the graph went very up in the infant mortality rate. So the government has taken some actions, restriction on import, and they have established many processing units to tackle the situation strategically. But still, the issue still going on internally. The people are still getting affected. So we should not make our nation something like this. So the prosperity, the science and technology should increase the prosperity of the people, make their lives easier, but should not take away their lives and should not ruin their lives into the soil. And the environment should not get degraded. Biodiversity should always be remained. The ecosystem should never get disrupted. If ecosystem or biodiversity gets disrupted, then the organisms will definitely get affected. So this is a situation, the real life case studies. So the assignment I'm giving you, I'm giving you 2 days of time. So just I have presented you only the few illustrations. Similarly, there are many kinds of incidents happening in many nations. So there might be somewhere else happening even in India as well. So now you need to make a research on different kinds of things going on. Make a detailed report. You can submit a handwritten report, or else you can submit like a Word document. So it's like a technical assessment. It's like a technical documentation for you. So just document. Go with the recent newspapers, published articles, gather information, and finally organize it in a proper way and submit it. So you can submit by the same email, admin@suchana.in. Just mention your name and the batch in the body section, and so the detailed instructions will be provided by our team. So this is about the uh, poor practices, right? So up to here, you have any questions? So do you think teaching how to design a PCB is enough, or you should at least know what are the things going on in the society, how PCBs are also affecting, taking the away the lives of the common people. So it is very essential. So that's why we have included this in our core curriculum. So I hope this is very informative. Now we will be discussing about the science, the chemical science behind uh, etching process of PCB. So before that, I just want to ask, so anyone in the meet can you just describe the term etching? So during our early sessions, maybe probably in the introductory session, we have discussed whenever you are presenting the slides on the manufacturing procedure of a PCB, we have very clearly explained the etching procedure, right? So what exactly the etching mean, how traces are formed. So can someone just in the Google Meet unmute yourself and explain the term as per your understanding?
Actually, when the PCB board, if it is placed in a chemical solution
Yeah,
to remove the unwanted excess copper or other substances which are present in the board,
right. Yeah,
this
perfect.
step is itching to remove the extra.
Yeah, right. So the chemical dissolution of copper is called as etching. So removal of unwanted copper or else dissolution of unwanted copper into the liquid solutions is called etching procedure, through which tracks are formed. So on the PCB, if you just observe the surface, we are having the tracks, right? Copper traces. So the only the copper traces are the required material. So the unwanted copper will be dissolved, gets dissolved in the liquid solution. It's a chemical process. So today we'll be explaining you the chemistry behind the chemical reactions which are behind the PCB etching process. So it's like a very detailed analysis of etchant solutions. So whatever the chemical that we use for etching process, we call it as an etchant. So it's like a detailed analysis of etchant solution. What should be the mixing ratios and proportion, and few reactions are exothermic in nature. So that means they emit heat energy. So this is very foundations of a chemical etching, understanding the subtractive methodology of circuit board fabrication. So there are three main core etchant families. Okay, there are three main categories of chemicals which are being used for uh, in the etching process for the dissolution of unwanted copper. So the first family is called as acid chlorides, and the second family is persulfates, and the third category is peroxide based. The first family is acid chloride, so it could be ferric chloride or cupric chloride. We'll be also seeing the reactions, how the copper is getting dissolved in the solution. Okay, so the first first category is acid chloride. So acid chloride, there will be some displacement reaction. So I know you might have learned the types of chemical reactions in your childhood, where chemical displacement method, chemical displacement reactions. These are very well explained in your childhood classes. So yeah, the first thing is acid chloride, and the second family is persulfate. So under the sulfates, we have ammonium persulfate, sodium persulfate solutions. So under acid chlorides, for examples like ferric chloride, cupric chloride. For persulfates, ammonium persulfate, sodium persulfate, these are used. And hydrogen peroxide and hydrochloric acid, this combination is also used. So which is very aggressive in nature. It's a strongly, highly exothermic, and it should be carried out in a strict temperature control because it is very aggressive reaction. So happens very quickly. Lot of energy, heat energy is emitted. It is very highly exothermic in nature, strongly exothermic. So it's a fast reaction, very fast acting reaction. So peroxide based reactions are very aggressive in nature, right? So very commonly used as an industrial standard. So because you need to know the industrial standard, right? In industries, which chemical is used for etching process. So most probably many industries right now still using cupric chloride for as an etchant. We will see in the later slides about that. Yeah, the very first reaction. So I told you there are three families: acid chloride family, persulfates family, and peroxide based family. Now we are discussing the first example for acid chloride family. It's a ferric chloride reaction. So ferric chloride, you know the formula FeCl3. So uh, weight by volume percent, approx 40% weight by volume. Uh, a saturated solution usually they take in the reaction. As you can see, the PCB has been placed in the ferric chloride solution. So the reaction is 2FeCl3 plus CO gives rise to 2FeCl2 plus CuCl2. Here the copper, as you can see, the additional copper from the PCB, it will be dissolved in the solution. So finally, it will be emitted as the cupric, uh, the ferric chloride reaction is, it is historically, it is widely used. It is an industry staple as well. And one more thing here, one more note has been provided, and there is a special mixture. So which we call it as Edinburgh Itch mixture. Just remember the name, Edinburgh Itch mixture. So basically they will be adding one more additional component to make the reaction. It's like a reaction accelerator, or else you might have heard the term catalyst. So the main role of the catalyst is to accelerate the reaction. It promotes the forward reaction. So basically reactions like forward, or it can be backward, right? So basically a catalyst accelerates the reaction in the forward direction and makes the reaction happen very quickly. So it speeds up the reaction. So it turns into fast acting. So usually in Edinburgh, it's like a small variant. The actual equation is 2FeCl3 plus Cu gives rise to 2FeCl2 plus CuCl2. The unwanted copper gets dissolved into the ferric chloride mixture. So the FeCl3 turns into FeCl2. You can also take the oxidation number and you can do those analysis later. So if you add a citric acid to it, maybe in the ratio. So if FeCl 4 parts of FeCl3 is taken, 1 part of citric acid to be added. So it will speed up the reaction. It acts like a catalyst. And then the second reaction, coming to the second one, cupric chloride, which is very widely used. So the color also different. FeCl3 is like something like this color, whereas cupric chloride it's like something like a greenish color, as you can observe on the image. So this cupric chloride is like a modern industrial choice. It is widely used. The reason is that it can be endlessly regenerated. So regeneration is very easy. So the equation is CuCl2 plus Cu gives rise to 2CuCl. Copper gets dissolved in the cupric chloride solution. CuCl2 turns into CuCl after the reaction. So basically this Cu is present in on the PCB, and this CuCl, okay, this is maybe something like in liquid form as a solution, liquid solution. So the copper material is dissolved in the liquid solution. So that's what etching process, right? Cupric chloride. So this is the regeneration equation. So you can we will share the PPTs as well. You can go through it. So there are alternative etchants as well. These are the primary etchants. It could be cupric chloride or else ferric chloride. Both fall under the acidic chlorides. Both are acidic chlorides. So they are widely used. They are the primary etchants. So there are these persulfates and peroxide based. These are the secondary etchants. Alternative etchant reaction, in other words. So all peroxide based reactions, I mean etchants and persulfate based etchants, they fall under alternative or else secondary. So they are not the primary thing. And persulfate etchants, so the ratio has also been provided. Around for 200 grams to 250 grams of persulfate crystals are dissolved in 1 liter of water. So in this solution of a persulfate, you need to submerge or dip the PCB. So there would be time frame also under which the reaction is carried out in a controlled environment. So the ammonium persulfate, or else you can take sodium persulfate. This is the equation: ammonium persulfate plus copper, which will be converted into copper sulfate and the ammonium sulfate. So ammonium persulfate is being converted into ammonium sulfate, and copper is getting dissolved in the ammonium persulfate. Finally, the end products we obtain are ammonium sulfate and copper sulfate. So this is a reaction. And moreover, one more important thing is it requires continuous heat. So this reaction should be carried out in a controlled environment where you need to continuously supply around, you need to maintain a temperature at something like around 45 degrees centigrade. So this ammonium persulfate solution, where you are taking 200 to 250 grams of ammonium persulfate crystals in 1 liter of water, So you need to dip the PCB, and the entire solution should be maintained at a temperature of 45 degrees centigrade. So it's not just like you are giving 45 degrees centigrade one time. You need to continuously supply the same heat. It should be maintained at the same temperature so that the reaction will get proceeded in the forward direction. So once if a forward reaction occurs, finally you will get the end products, copper sulfate and ammonium sulfate. That's how the unwanted copper is getting dissolved. Finally, you are getting a copper sulfate solution. And finally, the last family, the third family, acid peroxide etchant. So I already told you this is highly aggressive reaction, very aggressive reaction, happens within milliseconds, extremely fast. So this is called as fast acting etchant. So only acid peroxide etchants are called as fast acting etchants. So tomorrow we will be having a quiz session on chemistry behind etching procedure, and consumer safety, and different kinds of compliances like ROHS and FCC, Federal Communications Commission, restriction of hazardous substances, and CE, ROHS, FCC, and CE, and environmental safety, different case studies. So about polybrominated diphenyls and polybrominated biphenyls and polybrominated diphenyl ethers, and 10 restricted substances as per ROHS. And we are having an exciting quiz tomorrow. So yeah, these acid peroxide etchants are highly aggressive in nature. They are fast acting etchants. So maybe the question might be asked in the quiz. So out of these three families, what is referred as fast acting etchant? Acid peroxide based etchants are called as extreme. They are extremely fast and aggressive in nature. Hence they are called as fast acting etchants. Reaction happens very immediately, very quickly, rapidly emitting huge amount of heat. It's an exothermic reaction. Heat is emitted, and basically in acid peroxide, as the name suggests, we need to take an acid. And the one more material which is required is peroxide. We need an acid and we need a peroxide. So for acid, we will be taking HCl, hydrochloric acid. And for peroxide, we will be taking hydrogen peroxide. So when you mix hydrochloric acid with hydrogen peroxide, a lot of heat will be emitted. So therefore, it's a exothermic reaction, and it is very aggressive in nature. So also the ratio and proportion has been clearly described. 2 parts of a 3% hydrogen peroxide to 1 part of concentrated 30% hydrochloric acid. So 2 parts of a 3% hydrogen peroxide to be mixed with 1 part. So 2 parts of hydrogen peroxide to 1 part of hydrochloric acid. So coming to the percentage, the hydrogen peroxide is 3% and hydrochloric acid is 30%. So based on the volumetric, I mean the analysis of acids, right? About normality, molarity, about all these things, how these are being analyzed in chemistry. So this is the basic equation. So copper plus hydrogen peroxide plus hydrochloric acid, we get CuCl2 and water. So the copper on PCB is now turning into a solution. It is getting dissolved in the mixture of hydrogen peroxide and hydrochloric acid. Since we are using an acid and a peroxide, this is the acid and this is the peroxide. So therefore, this reaction is known as acid peroxide reaction. So acid peroxide family. It is very aggressive in nature. I repeat, I'm stressing. This is very important. It's highly aggressive. So now I have one question. While we are doing this reaction, so we are mixing H2O2, which is hydrogen peroxide H2O2, and HCl, right? Should HCl be mixed in H2O2, so H2O2 hydrogen peroxide, or else hydrogen peroxide should be mixed in the hydrochloric acid? So anyone? Should hydrogen peroxide should be mixed with HCl, or else let's say if HCl is taken in a beaker, so case A, where HCl is taken in a beaker and you are adding hydrogen peroxide as dropwise, and the second case where you are having hydrogen peroxide on the beaker and you are adding HCl as dropwise into the beaker. So will you be following case A or case B? HCl on beaker or else hydrogen peroxide on beaker? So let's see, because it's a very essential to understand. So manufacturing PCB is not just a technical thing. Just designing in a ECED and sending it to company is not enough. You need to know all this. What's the actual process going behind in the factory? How PCBs are being manufactured? What are the chemistry involved behind it? So it's very essential to understand. So here we are having a note. Always add acid to water, never water to acid. So here we need to always add uh, acid to water, never water to acid. So that's one of the equation that you need to remember. It is highly exothermic in nature. So that's an assignment for you. You need to learn. Uh, Namal is trying to join many times. Maybe some network issue. Yeah. So I have given a question, right? Just work on it. Uh, so the acid peroxide mixture is highly exothermic upon reaction. So when preparing the solution, you must add the hydrochloric acid slowly into the hydrogen peroxide. Just note this point. Hydrochloric acid should be added slowly into the hydrogen peroxide, which means here hydrogen peroxide, which is considered is like mostly water. It's like a water. Mostly it is compared with water. Hydrogen peroxide H2O2. The structure of H2, I mean water is H2O and hydrogen peroxide is H2O2. So H2O2, I mean HCl should be added slowly to the hydrogen peroxide. That means in a beaker you need to take H2O2. To that H2O2 you need to add HCl. So if you reverse this, if you have taken HCl in a beaker and if you are adding a hydrogen peroxide to it, so it is highly exothermic. Immediately lots of heat will be generated. If you are using the beaker gets heated too much, it may break. So a explosion will happen. So reversing this order cause flash boiling and splatter, highly corrosive. It's like a highly corrosive in nature. HCl itself is highly corrosive acid. So always control the bath temperature as the rapid etching reaction generates significant external heat. So this is the important thing, the exothermic safety and the mixing order. And coming to etchant solutions and comparison, here we are having a quick comparison. Ferric chloride, the etching speed is something like a moderate, slow to medium, moderate, and cupric chloride is very fast. So, and ammonium persulfate, it is also medium, but ammonium persulfate requires heat. You need to constantly maintain 45 degrees centigrade heat to make a forward reaction to happen. And acid peroxide, it's very fast, it's very aggressive in nature. And here bath color, whether it's a transparent or opaque. So ferric chloride already it has been clearly illustrated in the previous image. It is like something like a brown black color, and cupric chloride it is something like green color and very transparent. uh, Even you can clearly see the PCB which is dipped in cupric chloride solution. And ammonium persulfate it is something like a light blue, and acid peroxide solution it's something we call it as the color, we call it as emerald color. Okay, so this is about a quick comparison. Here is the regeneration thing. Only cupric chloride is very easy to regenerate. So from this table we can clearly understand that cupric chloride is the industrial standard, and it is very easy to regenerate. It is transparent in color, and I mean visibility it is like transparent, something like a greenish color, a light green. And the etching speed is also very fast, not very fast. It's not that much aggressive as like acid peroxide. So it's a fast, not very aggressive. So that's why cupric chloride is taken as the standard, because if you want to take ferric chloride, the drawback is that the etching speed is very slow to medium. So the let's say you have ordered a PCB and you want it very fast. You want the PCBs to be delivered very quickly. It should be shipped very quickly. So in production, if you go with the ferric chloride, the etching speed is very slow, slow to medium, very slow in other words, and it is very difficult to regenerate. If you go with ammonium persulfate, you need to constantly supply the heat. It requires a 45 degrees centigrade. It should be done in very highly controlled manner. So regeneration is always, almost impossible. It is mentioned, and acid peroxides, they are aggressive in nature. It's like a corrosive acid. So very fast exothermic reaction and highly aggressive, and regeneration is also not possible. Ferric chloride it's possible, but it's difficult to regenerate and it's expensive to regenerate. But cupric chloride, it is etching speed is also fast. It's not aggressive, but still is fast, and it's transparent as well, and it is easy to regenerate. and a little bit cheaper also. So that's why it is taken as the industrial standard. So from this we can understand the cupric chloride reaction. Cupric chloride is used as the industrial standard etchant. So this is images have been taken from these sources. So credits goes to actual owners. So this is about the chemistry behind etching process. So yeah. So I hope today's session is very informative. So today we discussed uh, some real world case studies happening in China and Silicon Valley. We learned about environmental safety and we discussed a few case studies, and later we discussed the chemistry behind etching process. So I hope today's session is informative. So this is today we are I think so actually we should spend one complete week according to the curriculum. 1 week should be dedicated for consumer safety in electronic appliances and the compliances, ROHS and FCC, Federal Communications Commission, and the CE and e-waste, the garbage disposal practices. So 1 week should be dedicated for these theory, so that uh, people will, the engineers and the consumers who are using will be very careful. So that's why we have included this in our core curriculum, despite it would be a little bit something like a chemical related thing, but it's very essential to understand. So from this presentation, few important things we can draw. So we have understood that ferric chloride is, if you just take the time into consideration, it is fast and it is transparent, something like a little bit greenish color, very a little bit non-expensive comparatively with other thing. And regeneration is the important aspect. So you can only regenerate the cupric chloride. So whereas regeneration of ferric chloride is also possible, but it is very expensive in nature. It's a difficult. And coming to hydrogen, I mean acid peroxide based family, so it is very aggressive and corrosive. So it's not preferred. Regeneration, there is no possibility for regeneration. So that's why cupric chloride is taken as a standard. So this is one of the important thing. So I hope today's session is informative. So in the next few minutes, I will be taking questions from you, probably in the next 2 or 3 minutes. So if you are having any questions, you can ask your question. I will be answering them. So then after we will be wrapping up today's session. I'm stopping sharing my screen. So if you have any questions, you can raise your hand or else you can unmute yourself and you can ask your questions. Could be related to the chemistry behind etching process or else environmental safety, compliances, or else from any technical thing that we discussed till today, starting from the schematics or from very introductory session, whatever questions that you have, you can ask your questions. So those who have no questions, now you can raise your hand. Let me see. Those who have no questions, you can raise your hand. So I know few people are joining the classes, but maybe due to their professional work or else due to some other thing, they may not be able to attend the live session, but they're still watching the recordings. Okay. So Sri Krishna can just summarize today's session. Yeah, we have Shikarani. Shikarani, can you just summarize today's session? What are the important points?
Yes. Today, first you talked about the environmental consequences and the health, health disastrous effects of the e-waste.
Yes.
We took the example of the Silicon Valley and we took the example of the China, Guangdong.
Right.
In Silicon Valley, it was the leak of the solvent, which is TCA, 60,000 liter leak in the drinking water well.
Yeah.
And in China, it is the e-waste mostly coming up by the extraction wrong, as basically not the proper procedural extraction from the PCBs for the, precious metals like the gold and silver.
Yeah.
And then we talked about the etching process, 3 different ways. To do that, you have the acid-based system, you have the sulfate, ammonium sulfate, persulfate.
Right.
Ammonium persulfate, and then peroxide.
Yeah.
right? 3 different systems. Then we talked about that FeCl3 will be, it's not transparent solution. It's difficult to regenerate and the reaction is slow. Cupric chloride is better because it's a transparent, so you can see what is going on. It's fast and we can regenerate it, and it is the industry favorite because of that.
Yeah.
Ammonium persulfate is okay, but it's not very fast reaction. It's still transparent.
Yeah.
Then it's difficult to regenerate. We can't regenerate it. And the last one was peroxide. We cannot regenerate.
Yes.
No. Yeah, last one is peroxide. We cannot regenerate. And it's a very fast, aggressive reaction, so it is not favored.
Yeah, right. So this is today's session. I hope it is very informative. So thank you for summarizing everything since starting. Thank you for joining today's session for 30-day PCB Design Challenge course. This is Hemant from Suchana, our dedicated mentor. Signing off. Bye-bye.
Thank you, sir.